Hi, everybody. Welcome to Q2B's Quantum Machine Learning and Ethics panel. Before I introduce the panelists, I just wanted to acknowledge this strange backdrop that we're all in, this world-changing pandemic, which for me has really illuminated the injustice and inequity in the world and has really made me reflect on how it's really important to promote ethical development of emerging technologies. So that's why I'm really excited for today's panel, and I am really excited to be able to start this conversation today with our panelists. So with that, let me introduce them. First, we have Katie Pizzolato, the director of IBM Quantum Strategy and Client Research. Next, we have Faye Wattleton, the co-founder of quantum startup Eeroq. And then finally, we have Kate Weber, the policy lead for quantum, robotics, and fundamental research at Google. Thanks, everybody, for being here.
Thanks for having us.
Thank you for having us. Yes.
Looking forward to
it. All right. So let's just get started. So my first question, which is to all the panelists, so to discuss ethics, we got to imagine the future and sort of speculate about what is likely and what is unlikely. So I want to know, what do you see as the trickiest or riskiest potential harms that the quantum industry needs to plan for right now? We'll start with Katie.
Yeah, so I think in a lot of ways, the things that we'll inherit from classical will bring us into quantum. I think that there are many things that we know about now that we're going to inherit as we go into quantum. As we know, quantum is not going to be general purpose. We believe it's going to be used for very specific things. And so a lot of the things that we'll inherit, from our classical AI and machine learning space will come with us. I do think that democratization and access, like broad access, as you kind of mentioned in your intro, the inequity that exists in the technology space sometimes it can be very impactful. A lot of us are able to work from home because we have access to a lot of different technologies. A lot of other jobs in this country haven't had access to that benefit. So I do think access to technology. We know the power of quantum and we don't want it in the hands of the few. So democratizing that access to our systems is really important. This open access and open source is really critical, a fundamental IBM goal and something that we've really been pursuing with our open source SDK and all of our open backend. So I think democratization, ensuring everybody gets their hands on the technology, is something that we all need to keep an eye on. And some of the things that we know about in the classical space, explainability, right? Some of those things might be trickier in quantum just because of the inherent, it's not quite as inherently obvious as some of the things, explainability in quantum space as well.
All right, Faye?
Yes, I think that there is no question that we will inherit a great deal from what has gone on before, including skepticism and suspicion and, in fact, resistance to the emergence of this new technology that will be enormously, at least initially, inaccessible. So I think that it will be a challenge, and the challenge is before us now, not in the future. The challenge is whether we're willing to continue to be reactive when there are ethical problems that arise and people worry about whether the robot is going to come through the door, or whether we will bring in a wider community for conversation about how we really can use this emerging technology for the good and for an accessibility that Katie spoke about in terms of democratizing the technology. But we're inheriting a landscape that is not the same as it would have been, or as it was 50 years ago. There's skepticism. There are calls for regulation. There are the perception that technology has been used to enrich a few, and that the broad vast of humanity has been left out. And so I think there are really real challenges, even though it seems inaccessible in large part because of the complexity of it. We have an enormous education and preparation to do. We don't have a workforce that is prepared for this next generation of information processing. So we've got a lot to catch up on. And though it may be perceived that this is in the way distant future, I think we're already behind.
Thank you. Kate?
Yeah, I would agree with what both Katie and Faye said about access and the fact that we need to think not just about actual access to tools. Google too has made as many of our quantum related tools open source as possible, and we're thinking about how to grow the user base for quantum computing technologies, but also the education aspect and how do you make access to what are right now a few machines? How do you democratize access to the actual technology and understanding and incorporate quantum computing concepts into a broader range of educational programs? I also think that there are very kind of short-term problems that have garnered a lot of focus within the community, like Shor's algorithm and breaking RSA encryption. And those are very clear places where we expect a societal impact. And there are a lot of things that we can do and are doing to prepare for that in 10 years, having RSA encryption broken by quantum computers. But more broadly, there is a lot to be learned from the classical computing space, and in particular, AI and machine learning and the many ethical questions that have arisen there at Google. And I can speak a little more to this later, but we have our AI principles, which very much shape how we approach specific projects on the classical side, but also now on the quantum side, to examine questions like fairness, privacy, et cetera.
Okay. I want to circle back to Katie and Faye because I wanted to ask you a little bit about applications, because Kate mentioned these cryptography applications. And I was wondering, for you guys, do you think is there a particular application that you are thinking about when it comes to ethics?
I mean, I think especially in this, kind of AI machine learning space, right? IBM has kind of come out already ahead of time and said, we're not going to do general purpose, facial recognition anymore. So I think, again, honestly, in a lot of the QML, like quantum machine learning spaces, there's a lot of questions on where quantum will play in the machine learning space. So I think the answer to the question of the applications that I concern myself with, or the things that we worry about in this space, are very similar to the things that we find ourselves concerned about in the classical space. Things that are not being prepared properly, or being built with prejudice, and I think facial recognition and things like that are some of those spaces.
Well, Eeroq has taken a bit of a different approach to this. We believe that this conversation needs to be open to a broader community, and that we should not repeat the patterns of the past, that it is within the industry that the conversations and the projections in terms of applications are made. And so we have made a commitment, a mission, to continue to build a base of experts in multidisciplines to look with us and to creatively think about how their professions will be impacted by the power of this technology. How do they see inequity? I mean, I think that the danger is when there's a great deal of groupthink, there's a lot that is not really thought about in terms of the future. And we really have a chance to really think about what may be possible that would not be ordinarily a part of the conversation of those people who are developing it, who are specifically looking for applications. And so we are convening a broader spectrum of multidisciplinary leaders to begin to think about and to dialogue about the applications for quantum.
Yeah,
Okay.
I completely agree with that. I think if we look back to, the most successful approaches in the classical AI space are that multidisciplinary, multi-stakeholder, multicultural based collaborative environments where we are producing open source, techniques. We're enabling developers to understand best practices. And, there's just a partnership on AI that many of the large corporations contribute to. And I think it's about collaboration, not competition in this space. We have to
And
come together and come up with the principles.
I mean, I am perhaps from a different point of view than the other people on the panel. I come out of the bioethics. My whole career is in healthcare, one of the most regulated industries in the world, in large part because of ethical violations and ethical missteps and a failure to perceive and project the impact of the work under the circumstances, presumably of doing good for the world. And I think the technology world is really loaded with that resistance at this point. And, I can go into lots of examples of how this can happen if we don't open the conversation before application, not reactive to application, and then contending with the problems thereby.
Yeah, actually, that's
go
ahead.
I was just going to say that on that last point, I mean, I think it's true that it's great that we're having this conversation now. I think I haven't seen a lot of conversations in the quantum space on this sort of broad topic of quantum computing and ethics. And it is important to start early at a point where we don't have these practical applications yet, but we can think about frameworks that allow us to approach them and to get the kind of multi-stakeholder input and learn from specific case studies as we move towards an error-corrected quantum computer.
I love the multi-stakeholder because we sometimes don't think about people outside the industry as being stakeholders and really having an impact, and should be engaged in the conversation as we're developing.
I wanted to seg into asking Faye. You already touched on this. You have this extensive background in healthcare, first as a nurse and then as president of Planned Parenthood for 14 years. And so I was wondering if you could give us some examples of what you think are lessons from the healthcare world that could be applicable to quantum computing.
Well, the lessons from the healthcare world are numerous. We're replete with violations, thus the most regulated industry imaginable. The IRB committees in hospitals are a result of the ethical lapses that have occurred in the practice of the healing profession. We know about the harvesting of genetic material against a person without the person's knowledge. We know about the Tuskegee adventures. I just, to put it very mildly or nicely, but the Tuskegee test, in which men were brought into a study and they had syphilis and they did not know that they were in the study. There are any number of lessons that we can take from bioethical principles that really could be very helpful to the conversation with respect to creating a framework for conduct in quantum technology. Now, there will be those who will say that that you shouldn't be engaged in making laws and restrictions, but what often happens, and we've seen it with respect to privacy violations and ethical violations around privacy, that those laws come about when there is a lack of consensus and a lack of commitment to a certain standard, and within the industry policing it, and as Kate said, with among stakeholders to really engage them to assure best practices and desirable behavior.
And
I mean, I was president of Planned Parenthood, so I certainly know also about the sterilizations without women's knowledge. So we could go on for this entire panel about that, which I know you're not supposed to, but there are lessons that we can take from other practices.
Can we also unpack what we mean when we say involving multiple stakeholders? Like, what, who are you currently reaching out to? And I guess this question is for everybody. So whoever wants to go chime in, go ahead. I guess Katie.
Well,
I was going to let Faye go because she was on a roll there.
Okay.
no. This is not my panel. This is our panel, guys.
No, it's good. I mean, I think that, yeah, like she said, it's not just stakeholders in the industry. It's recipients of what we're going to do. It's people that are going to be involved in the solutions, involved in their data, involved in how they participate in the conversation. So it's not just internal to IBM. It's broadly external, either different companies and people that we're going to work with to build the solutions of tomorrow. So one of my roles at IBM is to work with our industry partners in the application space. But something that's interesting when we talk about those applications, there's a lot of data that's going to go into those applications. So the creators of the data, the recipients of the output of the data, there's stakeholders really kind of at every level.
Okay. And Kate?
I guess I would just, if looking at our experience with our AI principles and their application in classical computing, I think we've learned a lot. As we were developing those principles, consulted extensively with nonprofits, think tanks, stakeholders, particularly looking at certain kinds of privacy issues. And now that we're putting them into practice, we've tried very hard to give an update every year on how that's going, what we're learning as we actually apply these principles. They're not just on paper. We're having to think through complicated cases where you might have conflicts between two of the principles, and how do you resolve those? And we've also thought about how to address things like explainability, developing model cards for some of our products, and have done an extensive stakeholder consultation to see how useful those are, if we're providing the kind of information, the right level of information. I think all of those lessons are relevant for the quantum computing space. And there is a lot of, we don't want to be reactive, but we do want to learn from each case as we go through it, and develop kind of a repertoire of case studies of what kinds of ethical questions we're asking, and how we can address them for the applications we're looking at for quantum computing.
Listen, let's not kid ourselves. Quantum computing is a game changer. This is the next generation. And do we really have to think about a game changer? What does this mean in terms of a world order? What does it mean in terms of realigning information as we know it? Who are the winners and who do we perceive are the losers that must not be the losers? And I recently read a paper about an example of technology that had entered the harvesting of tomatoes. And this was an industrial technology that made it impossible for the small farmers to make a living. And so they were put out of business. And I thought, how would we apply that to quantum? Well, the advancement of technology and science is not going to stop, but it didn't mean that those small people had to be put out of business. A redefinition of their role in the supply chain would save them. Perhaps there would be more product. Through quantum, we would have a better sense of where food insecurity could be most effectively addressed. And so I think there's a chance for us to have a big picture view of the world with the tools that are going to be possible, and that are increasingly possible because of the work by the colleagues here on this panel, the work that their institutions are conducting. I think if we continue to approach this as though it's a subject of case studies and examples, we're going to miss a big opportunity to think big about how the world is going to change, and how we have to be creative about addressing those changes and bringing people in to think big about folks, we're engaged in the production of a game changer, and the game changers are inherently good can be good and they are inherently dangerous. And so that's why this is an exciting time to be a part of this.
And I think too, there's so many, if we were trying to imagine, if we were sitting back when we started putting transistors on circuit boards, we would never have imagined the smartphone. So I think like Faye and Kate are both saying, like, the fact that we're engaging in these conversations now because of the lessons of our past, we've seen it now with, the rise of, like we said in the kickoff, of real AI and machine learning, like influencing our day-to-day lives. This is why we have to start now, is because we've learned those lessons, and we can't imagine everything that's going to happen with quantum, but we can imagine where it could potentially go wrong because we've seen it. So I think, just like you're saying, like the constant conversation and engagement of the conversation early is really going to be critical to where we end up.
Well, we're already engaging the conversation, so I don't think that's the future. I think that's the here and now. And you guys have resources to sell, so major corporations engaged with this, and I think that the opportunity is really past. When it comes to influencing public attitudes, folks, just think about the enormity of the task of educating people on what is quantum. Almost nobody knows. I mean, if you look at the general population, it's a very elite crowd of people who even have a clue about what this is. The enormity of that, let alone bringing potential stakeholders in to saying, how is this going to affect your industry, your sector? How do we think creatively about how we have winners and not just winners and losers?
Mm-hmm. Yeah. And of course, the challenge is too that we don't, as you've both said, we don't really know. It's hard to make those predictions because we don't have the computers yet. We don't know exactly what they'll be able to do. And at Google, our real focus right now is to try to uncover useful applications. And in doing that, certainly top of mind is which lines of research do we prioritize because we think they could lead to societal benefit. Of course, we can't really predict that, but we are trying to think about it. But it is going to be iterative because we're not at a point yet where we can clearly see what these applications are going to be.
Yeah, right. And Kate,
I don't think you have to wait. It's an evolving science, and people can move with you. There's an enormous amount of education and awareness that needs to be created. So I don't think it's an either or. I mean,
Kate,
folks, we have a really big job here.
Yeah. Kate, you were talking about, because I had asked a question about applications, and you were talking about how Google is focusing on making a frame. You just explain a little bit more what you mean by framework.
I think when I mentioned framework, I was referring to the kind of process we have for applying our AI principles. So, when we look at a particular research project or collaboration, thinking through the kinds of questions we should be asking about benefits to society, about privacy, about scientific rigor, fairness. Some of these questions will become more relevant once we get to the machine learning kinds of applications of quantum computing and other more sophisticated applications. Some we can sort of start thinking through the impacts on society that would come down the line, as Faye is saying. Like, I'm certainly not saying that it's too early to put in place this system for trying to ask the right ethical questions. But I think it's bound to evolve as we get to more sophisticated applications.
Yeah, and I think what Kate keeps saying too, like the opera, I can't get it out. Opera. Oh my gosh. Putting the ethics into practice through your operations and how you are actually approaching your product and things like that. That's a long process that doesn't occur overnight. And like you're saying, those frameworks that are going to allow us to do that are definitely going to be built off where we're starting today.
Well, we also have a generation of the future that we should begin now to kind of plant the seeds of ethical conduct and ethical values. That's an enormous task of educating our children around the potential. And I know that there are those who say this is a big waste of time, but you referred to my prior work before I became involved with Eeroq, and changing public attitudes and create, we're involved in a national conversation now in which misinformation and distortion of information is profound and harmful. And so it's a matter of keeping at it and recognizing that this is a very long haul commitment if we don't want to repeat the mistakes of the past.
So for someone who's working in quantum computing, who wants to promote ethical values in their own work, I just wanted to ask if you had any advice, like on the individual level, is there something that people can do?
Yeah, I mean, I think we've all kind of hit on it. Like, get engaged in the conversation now. Be a voice in your community, be a voice within your group. Like Faye just pointed out, the cultures that we create and the workforce that we build throughout this process, we need to infuse that culture in them. It's not going to happen on accident. I think publish your work, open source your work, be transparent about how you're building things. And I think, like we're saying, just keep asking, let's keep the conversation front of mind as the products continue to build and the technology continues to evolve. But I just be an advocate for this conversation is, I guess I would say, first for me.
I mean, I agree with you, Katie. Yeah. I listen to a lot of quantum podcasts, and they are all inside baseball podcasts. We love to talk to one another about this. We don't seem to love to talk to people who have no clue what quantum is, and yet that's really the task before us. And so we really need to open the circle. I mean, that alone would be. And recognize that there's going to be resistance because, as I said earlier, the perception with AI now is that the robot is going to come through the door, and how do we stop this from happening? That's not getting us to quantum. That's where we are right now. So there has to be also recognition that the playing field does have some resistance, which makes the job a little bit harder and scarier for people.
Yeah, I think I would echo understanding the importance of these conversations and also understanding what we can learn from what got us to this point of resistance on the AI and classical computing side, and how that community is now trying to address those issues. What lessons can we learn, and how can we apply those in the quantum computing space? And then going back to kind of the next generation, I think this is somewhere where across the board, not just in education of, quantum specific educational programs, but also computer science, physics, the kinds of lessons that the lesson that you need to be asking these questions, even if you're just an individual researcher. Like, these are not only questions for leadership to be asking, but everybody needs to be thinking about them. That's a lesson that should be learned across the board and can be applied, of course, to the problem that you're highlighting, Faye, in classical computing.
All right. So just to sum up, I wanted to ask each of you, what drew you to quantum computing?
I'll go first.
Kate, why don't we start with you? Okay. Kate, why don't you start?
Okay. So I am a molecular biologist by training, but have since moved into a career in science policy. And for somebody who's interested in the intersection of science and policy, quantum computing is really compelling just because of its expected power and possibility of transforming our society.
The majority of my career has been spent in healthcare, and I've spent a great deal of time traveling around the world and seeing the inequity and the disparity. And I was drawn to quantum computing or quantum technology because I think it does offer the potential to make life better on this planet for those who have not had access to this kind of this influence.
Yeah, and I think I would say, which we've kind of all hit on, right? It's not only what's next, but it's a game changer. And I think what's particularly interesting about it is because of all of the other modern technology that we have in modern infrastructure, cloud, open source software stacks, really strong communities. We're gonna be doing a lot of this in parallel, and so I think to me, it's like a big race in your head, right? There's a lot of people racing to build the hardware, and we're racing to figure out what to do with it to make the most impact. And I think that's pretty exciting.
Great. Thank you to our panelists, and this concludes our panel today. I hope everybody had a good time.
It was great.
Thank you,
It was fun.
Sophia.
Thank
Thank you,
you.
Katie and Faye.
Thank you for having us. It's perfect.